Welcome back to the 7th section of Chapter 5. This is beginning the second part of the chapter. So the first part we were looking at quadratic equations and quadratic functions. We started out by graphing quadratic functions and then solving them. This section we're going to look at quadratic inequalities. And so we'll have greater than or less thans. We'll be graphing and we'll be solving. The nice thing is that this really is not much different than the way we did it with lines, except that we now have quadratics. So let's look at our learning targets. I can solve quadratic inequalities using tables and graphs, and I can solve quadratic inequalities using algebra. And so the first thing that we have is quadratic functions, and these are going to be two variable functions. We're going to graph f of x equals x squared, or not equals, f of x is less than x squared plus 3x plus 7. Y is greater than x squared plus something. And so we're going to be looking at this by graphing. And so when graphing inequalities of any type, there are two big differences. The first is the line. Is it solid or dotted? And the second is shading. We're going to shade one side or the other. And so the first, we're going to look at the line. We look at the signs. If it's just the less than or greater than, as opposed to less than or equal to, greater than or equal to. The less than or greater than are going to give us the dotted lines and open points. Those will be the open lines are dotted, and open points are the ones that aren't filled in. And the or equal to give us solid or closed lines and closed points. And so open points look like that, and closed points look like that. And then shading, we plug in a point on one side of the line, we shade that side if it works. If it doesn't work, we shade the other side. Now if you have y equals or y is less than, you'll shade below. If you have y is greater than, you would shade above. But sometimes when it's all mixed up, it's a little bit tougher to tell. Two pro tips for graphing quadratic functions and quadratic inequalities. The first one, graph paper. Use graph paper. It makes it so much easier, neater, more accurate. So many reasons to use graph paper. And the second one, use a pencil. Because when you're doing the solid or dotted lines, a lot of times the dotted line is an afterthought. Well, the cool thing about pencils is down here on this end, you've got the business end of the pencil. That's the end where you're making your lines, doing all your work. And, little known fact, on the other end of the pencil, you have this little guy. And that's called a dotted line maker. It turns solid lines into dotted lines, and it's magic. So using a pencil really helps. Pens do not have dotted line makers, and so that gets really messy. All right, so to graph these, if we start out with an inequality, y is greater than negative 1/2 x squared plus 3. We're going to make a table. So we can plug this into our table and find some points. Start out with the vertex. How do we find the vertex? It's still negative b over 2a. Well, b is 0, which would make the vertex at negative 0 over 2a, which is just 0. So we can start at 0. And then go out from there. Negative 1, negative 2, 1, and 2. Now we can plug in these values to x squared. And so we'll have negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Then we can multiply by negative 1/2 to get negative 2, negative 1/2, 0, negative 1/2, and negative 2. And then add the 3 to get 1, 2.5, 3, 2.5, and 1. And so by plugging in these values, we can get to our y values, which can then get put into our table. And from here, once we have them in our table, we can graph the points. We're going to take x comma y, so get our graph paper, and we can plot points. Negative 2, 1, negative 1, 2.5, 0, 3, 1, 2.5, and 2, 1. Connect the dots in a parabolic fashion using So we connect the dots in a parabolic fashion, and then we think, oh wait, solid or dotted? This is just greater than. It's just dotted. So using the dotted line maker, we can go through and make it a dotted line. And then shading. In this case, I would plug in the point 0, 0. Is 0 bigger than 3? No, 0 is not bigger than 3. So this point doesn't work, which means none of these points in here should work, which means the points on the outside should work. So we'd shade the outside. And then, how about try one? So notice that this was the same as graphing a regular quadratic, except we had to think about the dotted line and the shading. So go ahead and try one. Try this one. Y is less than x squared plus 2x minus 5. Go ahead, try it. Push pause. Try it. And then when you're ready, come on back. How'd you do? Did you get it? Does it look like a parabola? So, first step, make a table. The vertex is -1 because -2 over 2 times 1 is -1. And we can go either direction from there. -2, -3, 0, and 1. And plug those in and simplify. You should get these numbers. So -3 gives us -2, as is 1. 0 gives us -5, same with -2. And -1 gives us -6. And plot those points in a graph. And then connect the dots. This one's still a dotted line. So the graph should look kind of like that. And then graph it. If we plug in 0, 0, 0 less than 0 plus 0 minus 5. No, 0 is not less than -5. So we would shade on the other side, which would be outside the parabola, which is where y is less than the equation. Now here, greater than we shaded outside. Here, less than we shaded outside. Notice the parabola is flipped. Here we shaded above, and here we shaded below. It just happened to both be outside the parabola. Now looking at quadratic equations, this is where we're only going to have one variable. We're going to have like 0 equals x squared plus x. Well, not equals, greater than or less than, or x squared is less than 10x plus 2, things like that. We only have one variable. Our answers aren't going to be graph. It'll be things like x is greater than a number, x is less than a number, x is in between two numbers, things like that. With equations, this is where we had like x equals 2, x equals 3. And so there's two ways we can do it. The first, using a graph and a table. And the second is using a number line. So using a graph and a table, if we start out with one, 2x squared plus 3x plus 6 is greater than or equal to 5, we're going to graph both of these separately in y1, or if we're using a graphing calculator, put it in the first y and the second y. Or if we're graphing by hand, we could just graph this. But if you're doing it by hand, I would solve it using algebra. And so we're going to plug it into a calculator. So y1, plug in this side, and y2, we plug in this side. And then we're just going to look to see when is y1. In my case, it'll be the blue graph. When is that bigger than the red graph, which is y2? So we can graph it. And it's bigger over here. And it's bigger over here. And there's this little spot in the middle where it actually gets smaller than the red line. And so where are those values? For that, we can look at the table. So you can go to the table, and we see, hey, it's equal at -1. And so it's bigger when x is less than -1. And then I don't see the equal, but it's going to be right in here somewhere, kind of in between -1 and 0. So we can change the window set or the table set, change it so instead of going up every 1, it's going up every 0.5. And we can look at the table, and we see, okay, so -1 it works, and -0.5 it works, and oh, look, it's bigger on all of these numbers too. So as long as we're less than -1 or bigger than -0.5, we should be good. So x is less than or equal to -1, or x is greater than or equal to -0.5. The or equal to is because the problem had or equal to. That does not change. And if we're going to do it using a number line, we can have our graph, x squared plus 27x is greater than 12x. We need to solve it, so let's move the 12x over. X squared minus 12x plus 27 is greater than 0. Now we have several ways of solving this. When we solve it, we're going to solve for pretending that it's equal to 0. And so the first step I would use is factoring. I'd look at it. Can I factor this? What two numbers multiply to give us 27 that might add to give us negative 12? Well, 9 times 3 is 27. Hey, make those both negative. So we'll have 9x minus 9 and x minus 3 is greater than 0. If you can't factor it, go to quadratic formula or completing the square if that's your preference. So we have x minus 9 times x minus 3 is greater than 0, which means x would be, we can pretend it's equal 0 for the moment, and so x equals 9 or 3. Now we can make a number line and put those on the number line. At those points it'll equal 0. We're going to figure out, all right, so how about on the outsides of the points in between? So if we pick a number less than 3, say 0, we're going to plug in 0. I would plug it into this equation where it's greater than 0. Or this equation, because this will give us positive or negative. If it's positive, it'll be bigger than 0. If it's negative, it won't be bigger than 0. So we'd have negative 9 times negative 3 is going to be a positive number, so that's bigger than 0. Negative times a negative is a positive, which is bigger than 0. True. And then plug in a number in between, like 5. Plug it into our factors. 5 minus 9 is negative. 5 minus 3 is positive. A negative times a positive is a negative. And is a negative number bigger than 0? No, it is not. So it doesn't work in between 3 and 9. And then one bigger than 9, like 20. 20 minus 9, 20 minus 3, those are both going to be positive. A positive times a positive is a positive, and positive numbers, yes, are bigger than 0. So where does it work? It works when x is less than 3, and it works when x is greater than 9. So x is less than 3 or greater than 9, and those should not be or equal to's. It did not start out or equal to's. It should not be or equal to's here. It's just less than 3 or bigger than 9. All right, another one. How about this one? 3x squared plus 6x plus 11 is less than 10. First step, subtract 10. That way it's equal to 0. And now we can factor. Or in this case, that's not going to factor very well. So we can use completing the square or quadratic formula. I picked quadratic formula, so let's plug it in. Negative 6 plus or minus 6 squared minus 4 times a times c, that's 3 times 1, over 2 times a, that's 2 times 3. We can simplify. 6 squared is 36, minus 12, and that'll be over 6. 36 minus 12 is 24. And so we have negative 6 plus or minus root 24 over 6. Root 24, that's 4 times 6, which the 4 can be square rooted to be 2 root 6. So you have negative 6 plus or minus 2 root 6 over 6. And then I recommend splitting up the fraction here. It makes simplifying easier because you can do each piece separately. So that's negative 6 over 6, which would be negative 1, plus 2 root 6 over 6, which would be 1/3 root 6, or root 6 over 3. So we have our answer. It's not a pretty answer, but we do have an answer. And so we can plug it into a number line. Get a number line. We're going to have negative 1 plus root 6 over 3, negative 1 minus root 6 over 3. Which of those two things is going to be the smaller of the two? Minus. Right? Because if we add, we make it bigger. If we subtract, we make it smaller. So the subtraction one's going to be the smaller of the two, which means the addition one's going to be the bigger of the two. Now we need numbers to plug in. Well, what is root 6 over 3? Or negative 1 minus root 6 over 3? I don't particularly know, don't particularly care. It does not matter. What matters is I get a number less than that. So let's go way less than that. Oh, and a number in between. Number in between is easy. What's in between -1 plus or minus anything? -1 is in between there. And so if we plug in -1, we can get 3 minus 6 plus 11 is less than 10. 8 is less than 10, which is a true statement. So yes, it works for -1. Then a number less than that, -10. This isn't going to be anywhere near -10. So choose -10. So plug it in. We can multiply. So 300 minus 60 plus 11 is less than 10, which we don't even need to figure out what this is, because no, that's not going to be less than 10. 300 minus 60 plus 11, no, that's way bigger than 10. And then a number on the other side, like 1. And so we can plug in 1. 3 times 1 squared plus 6 times 1 plus 11 is less than 10. We simplify. 3 plus 6 plus 11 is 20. It was less than 10. Is 20 less than 10? No, it is not. So where does this one work? It works in between these two. It's just a less than, so we'll have this number is less than x, which is less than this number. If this was less than or equal to, these would be less than or equal to's. But it's always the small number is less than x is less than the big number. That's if it's in the middle. On the last slide, we saw what happens when it's on the outside. We have x is less than this, or x is bigger than this. So how about try one? X squared minus 14 is greater than or equal to 2. So go ahead, pause the video, try this, and then come back when you're ready. All right, how do you think you did? So first step, add 14. So we get x squared equals 16. I know it's greater than or equal to. We'll get back to that later. And then square root. So x equals plus or minus 4, which means we can do a number line. -4 and 4. We need points on the outside and in between. So -10, 0, and 10. If we plug those in, yes, it works on the outside, on both sides, and no, it does not work on the inside. So you probably chose different numbers than I did, but when you plugged it in, did you still get yes, no, and yes? So this means that x is less than or equal to -4, or x is greater than or equal to +4. You can't really do a plus or minus there because the signs go different ways, so that doesn't work. And so that's solving a quadratic function with one variable. Notice this one we didn't even have to use completing the square. We just use square roots. If you're completing the square, you'd have 0 for a b term, which ends up getting in the same place, but going through a lot of extra steps. And then one more to try. X squared minus 4x minus 5 is less than or equal to -9. So go ahead and pause this. Try this one, and then push play when you're ready to come back. All right, how'd you do? Did something weird happen at the end? I guess define weird. So let's solve this. First step, move the 9. So you have x squared minus 4x plus 4 is less than or equal to 0. Now we need two things that multiply to give us 4 and add to give us -4. Like, say, -2 and -2. So x minus 2 times x minus 2 is less than or equal to 0, which means x equals 2 or 2. So we only have one number to put on the number line, 2. We can look before the 2, we can look after the 2. Before the 2, we can plug in 0. Well, we have 0 minus 2 is negative, and 0 minus 2 is negative. Is negative times a negative going to be a positive, which is not less than or equal to 0. So that doesn't work. Then if we plug in another one, say 5 on the other side, 5 minus 2 is positive, 5 minus 2 is positive. Positive times a positive is not less than or equal to 0. So it's positive there as well. And so then, well, where does it work? In this case, the only place where it's less than or equal to -9 or 0 is at 2, because at 2 it equals 0. If this wasn't an or equal to type situation, it would be no solution. And we'll see that. But let's see what it looks like. It's above in both situations. So if we graph this, we have -9, and then we have our parabola, and that's the only place it touches. It's always above -9. We're looking for when it's below -9. That never happens. We could look at the table. There's -9, it happens there, but then it's always greater than -9 in both directions. And so it is possible where in this case we have a point, or if it wasn't or equal to, we would have no solution. It would look like that. But it is or equal to, so it's just x equals 2 is the only answer. And so that's looking at quadratic functions and quadratic equations. Quadratic equations we're solving the same way we've been solving them for the past week, except that we have to deal with the inequalities. And graphing, we're graphing them the same way we were, except that we have to look at the inequalities. So I will see you later, and until then, happy mathing.